Welcome to this Postgres Vision talk. My name is Gordon Platt, and today I will be discussing a few things that are not in the xDB user manual. The talk is called Tips and Tricks DB 6.2 Logical Replication, Things You Won't Find in the xDB user manual. I work for MasterCard in Brisbane, Australia. Today I will be covering things like how to manually reconfigure xDB to replicate to different hosts, how to manually create a replication slot or replication origin for xDB, how to fix xDB when you get a message saying Snapshot is pending for the target node, how to do housekeeping of xDB events, how xDB replicates Truncate and how to stop Truncate from replicating, using xDB as a data migration tool with filtering and Postgres triggers, how to get xDB replication working again when it stalls due to data issues, how to get xDB replication working again when you're faced with duplicate key violations, and finally, how to build an MMR node using offline snapshot without data loss. And very briefly at the end, I'll just talk about the future EDB replicate. And just very briefly about MasterCard. MasterCard, as you can imagine, it's 50 years old, got a whole set of different database technologies, including all of the usual suspects: Oracle, Postgres, MySQL, Microsoft SQL Server, Cassandra, Hadoop, DB2, for example. And in the case of the payment gateway that I support, MasterCard acquired this as part of a company acquisition in 2014, and with it came Postgres. By a happy coincidence, MasterCard was already using Postgres. At the time, Postgres binary streaming replication was the major tool of the disaster recovery strategy, and trigger-based Sloney was used for major Postgres upgrades. 2016, a decision was taken to evaluate multi-master replication, and EnterpriseDB's xDB offering was chosen. And in terms of the gateway itself, typically a couple of million card transactions per day, peaking at around 150 card transactions per second. And xDB is used to replicate the transactional data to a second remote data center that will be at least 1,000 miles away or 1,500 Ks away. And high volume payment gateways must say use Oracle, but at MasterCard, the command line interface is used rather than the GUI. This allows for automation of key tasks. So you'll notice throughout this talk, I use the command line commands. So the first thing I want to mention is a few things just to not forget before starting xDB for the first time. This is all in the manual. So in the PostgreSQL.conf, make sure you've got the WAL level set to be logical for logical replication. Max WAL senders shouldn't be 0. Max replication slots shouldn't be 0. Track commit timestamp must be on. In your pghba.conf, make sure that your Postgres server will accept replication connections from the host where xDB is running. Make sure that it will also accept regular Postgres connections from xDB. And if you're using xDB filtering, please remember that you need to have replica identity full set, which basically means it will actually provide both the before and after image on an update of the values of each column in the table. And that I've included the schema there doing alter table, table name, replica identity full. So let's now move on to configuring xDB to replicate to a different MMR node or different port. You might want to do this, for example, when the IP address is being changed because, say, the hardware has been moved onto a different subnet. Maybe there's been a DR event. But now what you can do firstly is use the Java -update pubdb to actually do this for you. I must say that works very well normally, but there's a legitimate situation where it might legitimately fail. And typically, in particular, that might be when the active controller database IP address is also changing. Now, the active controller database is referenced in the /etc/edbrepl.conf file, and you'll see there's a host entry in there. But the thing I wanted to mention, and I'm sorry, I want to mention that first, but the thing I wanted to mention in particular is the MMR host IP addresses and ports are stored in a table called xDB pub database. And you can see I've done a select from a sample table, and you can see in there you've got the pubdb ID, the host, the port, the database name, and whether it's an MDN node or not. And I've don't forget, just double check the active controller host name in the etc edbrepl.conf file. So the steps that you would actually go through, just very quickly, would be to actually stop xDB. If the current active controller database IP is changing, then update that file, edbrepl.conf, as I mentioned on the previous slide. And then just do an update of the xDB pub database table, setting the DB host to the new IP address, optionally changing the port if the port is changing, and of course a new where clause where the DB host was the old IP address. And the big thing to remember is repeat that for the other MMR nodes, and don't forget those, because otherwise, when you switch active controllers, all of a sudden it'll be trying to replicate to the wrong hosts again. So let's now talk about manually creating a replication slot. So, and we'll come on later to one of the situations where you might want to legitimately do this. But a slot name has three components to it. The first is a string, xDB. That's pretty obvious what that's all about. And then there's the second part is the OID of the database that the slot is associated with. And the third part is the publication ID. And the command that you would use is pg-create logical replication slot is the function that you would use. And you can see that the separator for each of those components of the name is actually the underscore. So yeah, so as I mentioned, the first part is xDB. The second part is the OID. Now you get the OID from the PG database. So do select OID from PG database where dat name equals the database name. I've included the SQL there. You get the OID out. And then the third part is the publication ID. And you get that from the xDB publications table. So if you just do select pub ID from xDB publications, it gives you the pub ID. And those are the three components for doing your creating your logical replication slot. Okay, now the next thing to mention is manually creating a replication origin. Replication origin is very important to help prevent data ping-ponging backwards and forwards. So that is, if you do an insert into MMR node number 1, it will replicate to MMR number 2. You don't want that insert to then try and replicate back to MMR node number 1 again. And in this case, the replication origin name has 4 parts. Again, the first part is the string xDB. The second part is the database name. Third part is the publication name. And then the fourth part is the publication DBID. And you can see that the pub DBID is obtained from the xDB pub database. And the function that uses PG replication origin create. And I've included an example there. So you can see there I've got xDB, DB name, which will be obviously your database name, the pub name, and in this case, the pub DBID is 454, just in this example. And we'll be using that again later in one of the other tips and tricks. So supposing a snapshot fails and we then get a warning from xDB saying that the snapshot is still in progress. And I've included there an error straight from the xDB log file warning the snapshot is pending for the target node, sync cannot be performed. So the reason that comes up is because there's a column in a table called xDB MMR pub group called has initial snapshot. And that's where xDB records whether there is a snapshot in progress. Typical values will be Y for yes, the initial snapshot is complete, or I in progress, that is, it's in progress and not complete. And I've included some sample output there from a select off that xDB MMR pub group table. So yeah, if the snapshot does fail, then it's very important that you check that it has initial snapshot value in each and every MMR node, similar to what I said earlier, that if the active controller suddenly is changed, then all of a sudden xDB will again think there's a snapshot still in progress if you haven't done that. And I've included the update statement there. And the other thing to remember is if this happens, there's two main situations you may see this happening. One is when you're building an MMR node and you're doing a snapshot copy, that you might get this problem. The other situation is if you're doing DDL and actually adding a table to the replication publication set, and it then gets confused and doesn't actually manage to update the table correctly for whatever reasons. And that's the other situation where this may happen. And in the former case, you'll have to manually correct the replication slot and replication origin because xDB is most likely hasn't done that for you. And so that's why I mentioned that there. And of course, that's something that we've just covered in one of the previous slides. Okay, so let's have a look at xDB housekeeping. So what I find sometimes is that cleanup replication history can be a bit of an issue, and particularly if we're doing large volume of transactions per day as we are on our payment gateways. So what happens is within xDB, it actually tidies up the rep log and events table. So there's 4 of them that it tidies up. And if it didn't do that, they just grow and grow and grow. And but the problem is that if they've got, it tends to try and do those in one large transaction block. So xDB can struggle to process the large transaction blocks of millions of deletes, and there'll be replication lag while xDB is slowly processing the large volume of deletes. And there is a risk, although I've never seen this happen, it just might be unable to process the vast number of deletes. So there's 2 ways that we can work around that. And I should say this was developed in conjunction with EnterpriseDB. So the first workaround is to actually truncate those tables. But of course, you can't truncate them on the active controller, you truncate them on the inactive controller. So basically, first thing to do is identify the inactive controller database or databases. And because if you remember, I've already mentioned that the active controller IP is written to etc. edbrepl.conf, and therefore the inactive one is basically the MMR nodes that basically aren't referenced in that file. And then so for each of the inactive controllers, what you want to do is just truncate those 4 tables. And in the case of xDB pub replog, do it with Cascade. I think the Cascade actually cascades to the xDB pub table replog. And the xDB event status. And then, of course, once you've done that, you don't get the benefit until you switch active controllers. And there's a Java command for that, which is the Java -setters controller, which I've mentioned there. So the advantages are that truncate's not logged, so it has 0 impact on replication because it doesn't get written to the wall stream. And Truncate instantly fixes any bloat issues as well. Disadvantages are just a minor risk of removing important data. Now, at MasterCard, we use this Truncate solution rather than what I'm going to show you on the next slide, but you'll notice the slight difference. So I did raise a support ticket with EnterpriseDB, and they very kindly provided this SQL code that can be used. And the idea of doing the SQL code is by using the limit, you can actually see, you can actually restrict the number of rows that are deleted in one transaction block. Now, I should say we've never used this at MasterCard, so this is not tested here, but this was provided by EnterpriseDB. And the big difference is you'll notice in the case of the second delete statement, in the where clause is where event status in CD. So this guarantees that it won't remove any events if the value is C or D. And that is the big difference between just truncating and doing the delete in this way. So in this example, I've chosen small time frame. I chose 25th of May 2019. I'm not quite sure why I chose that when I was doing the slides, but the idea was to just show small time period and limit the number of deletes to say 1,000 at a time, and then you would just loop through until you deleted them all. And as I said, at MasterCard, we use the Truncate solution. And typically, low volume payment gateways probably run that twice a day, and the high volume payment gateways will run that 4 times daily. So let's now have a look at manually adding a table to the publication. Now, there is a Java command for this, Java -add tables into pub. And but there may be situations where you don't want to actually use that Java command. And also, with this being tips and tricks, I'm going to show you the other way to do it. And what you want to do is insert into 3 tables, which is rep tables, rep publication tables, and xDB conflicts options. So first table to insert into is rep tables. And the main thing here that you need to know is it's all very obvious in terms of specifying the schema name, the table name, and what have you. But the one thing is, where do you get the table ID from so that it's unique? And you get that from the rep common sequence, which is basically a Postgres sequence. And just do a next val on that to give you the next value in the sequence. And there's the SQL there for you. So yeah, so before you can actually do the second insert, you actually need to know the publication ID. So I've included the SQL there. You get the publication ID from the xDB publications table. I think I've mentioned that before. And you also need that table ID. So whatever that sequence value was that was provided by Postgres from that sequence, you need to know what is. So just do select table ID from rep tables. And obviously in your where clause, specify the schema name and the table name, and it'll give you the table ID. So you then need to insert into rep publication tables using that publication ID and table ID, and I've shown you the SQL there. And then what you also need to do as well is insert into the xDB conflicts options table. So if you remember with MMR, conflict handling is very important. Now at MasterCard, we generally go for earliest timestamp, but you could go for latest timestamp. You could go for no priority. You could actually have a custom function to deal with conflicts for you, or it could be a free-for-all, basically the manual method. And so with xDB conflicts options, again, I've just shown you an insert there with your table ID, the resolution strategy just being a single character, and don't forget your publication ID and the table ID. And also what I've got at the end here, of course, is please don't forget to do this in all the MMR nodes, because otherwise, when you switch active controllers, all of a sudden this table won't replicate anymore. And those are the important things. So just don't forget that. And of course, when you do this on the second MMR node, you don't do a next val of the sequence. You use the table ID number that was used. So please just remember that. So there's one other thing that you have to do is I've told you which tables to insert into and the values that you would typically use. But what you've got to remember as well is truncate is not replicated. So supposing in your application you want truncate to actually replicate. So xDB will support this, and the way it supports this is with an after truncate trigger. And what happens is you basically need to create a trigger for this particular new table, and the trigger must fire a function called capture truncate event. So you can see the create trigger syntax there typically. So create trigger, trigger name. The convention is it starts RRPT underscore, and it's an after truncate trigger. So after truncating on that, called that function capture truncate event. And if you don't create this trigger, then truncate will not replicate. So if you truncate on MMR node number 1 and this trigger doesn't exist, then xDB will not replicate that truncate to MMR node number 2 or any other nodes you've got in your cluster. So yeah, and then just briefly, just talking, what are the advantages of doing it manually? It's good when table snapshot is not required. So for example, that might be a situation when, this is when you're doing DDL, I should say, to add a new table to the publication. So for example, if for whatever reasons you've got the tables are already populated and you've got different data in MMR node for MMR2 node number 2, and that's actually by design, then this avoids the snapshot. And so it's good in that situation. I also find that you may choose to use this if Postgres is under very heavy load, because XDB will then struggle to create the table in the MMR node. So what I mean by struggle is it has to wait for exclusive locks and stuff like that, and it can take its time sometime to do that. And of course, one of the disadvantages, it's not documented, it's a manual procedure which is prone to error. And of course, the steps might change with new releases of XDB. You know, there may be a new table or there may be a new column, for example. And the other interesting thing about this is once you've inserted into those 3 tables, you don't need to restart XDB. XDB doesn't seem to cache the tables for publication. It seems to go back to the tables and reread them regularly. So once you've inserted into those tables, it will just start replicating those tables. So replicating the new table, I should say. So just a little bit more on how XDB replicates truncate and how to stop it. So I mentioned already that there's an after truncate script, an after truncate trigger to facilitate the replication of the truncate DML to all MMR nodes. So how does that actually work? So what happens is the capture truncate event function actually inserts a row into the rep-wall events queue. And typically that row consists of the current xlog location, the current transaction ID, the current user, the table name, the text DML, the text truncate, and the current time. Okay, so what I'm going to explain now is just a little bit more about how XDB replicates truncate and also how we can stop it replicating truncate. So what happens in this situation, as I mentioned on the previous slide, is that it inserts into the rep-wall events queue table. And when XDB polls that table, it'll typically get back the values that I've listed there, which is the event ID, the wall LSN, transaction ID, the event object, basically the schema and table name, and the command. In this case, it was truncate, of course. And what will happen then is that XDB will actually then, at the appropriate point in the wall stream, because obviously it knows what that is, it will then issue truncate on each and every MMR node. And so that's basically how it works. So within a few seconds of you doing truncate on MMR node 1, it will have truncated on each and every other MMR node in your cluster. So if you don't want it to do that, then the easiest way is to drop that trigger for the table that you don't want to replicate it for. And remember, you've got to drop it from each and every database that you're replicating to and from. And if you want to script that, so for example, if you want to just stop truncate full stop on every table that's replicated, then just do a PG dump of the schema, grep for the trigger, where you remember the trigger name is starts rrpt underscore, and you can then quite easily script something to generate the SQL that you need to drop all of those triggers. And that works well. I mean, I've dropped 350 or 400 triggers in one go very easily using that technique. Okay, so let's just talk briefly about using XDB as a data migration tool with filtering and Postgres triggers. So at MasterCard, we had an issue that we needed to transfer a large quantity of data from Australia to India for regulatory purposes. And basically we needed to replicate just a subset of that data. So not all of the data that was in Australia had to be replicated to India, and some of it contractually we weren't allowed to. So obviously we weren't going to do that. And so what we did was used XDB filtering and also Postgres triggers. And so XDB filtering works well. So on the OLTP tables, we typically filtered on, so you can filter on, say, a currency code or a country code. So when XDB read the data from the wall stream, it would, and you've got to remember the filter basically, it's basically a where clause. So it would just look at the data and say, where the currency is is X, and say, oh yeah, it satisfies that criteria, therefore I will replicate it. And then it'll say, oh no, if the currency doesn't equal X, then it doesn't replicate it. And that worked well for us. And the thing is, there was about 30 tables that had data filtering enabled on them. So of course then it was a bit of a handful to actually administer the filters for those 30 tables. So what I actually did in that case was I actually put together a config file where you had basically the schema name and the table name, an identifier, the filter name, and the filter where clause, all colon separated. And then once I'd defined those, I should say as well, there was a symmetry about the filters. They were all doing very similar comparisons because it was basically the same business logic saying, does it satisfy this criteria? Therefore, yes, we replicate it. And so therefore I was able to basically script actually generating the filters themselves from the list of tables. And then I was also able to script the generation of the filters. And I've included just a little bit of sort of shell pseudocode there, just showing how that I was able to basically from that simple config file, just extract the filter table name, the filter string, check that the filter didn't already exist, and then do the Java command to actually add the filter to the publication, to the MMR node. And that, again, that worked well because it just meant just run the script, and a couple of minutes later, all the filters were in place, and that was good. And I had a similar script to actually drop them again when we didn't require them anymore. But there can be problems because, of course, where we're only migrating some of the data, that meant that occasionally there would be subsequent transactions that were being done on data that hadn't been migrated, but that data, with the filtering that was in place, would attempt to be inserted into the India instance, so into the remote MMR node, the target MMR node. So in that situation, basically, I added a set of triggers to actually test for whether that data could or couldn't be inserted. So what this is doing is it's effectively adding additional business logic to make sure that the data that's in the target is referentially correct. And so if you've got version 2 of a transaction and version 1 didn't exist, the idea was that it wouldn't insert version 2. But xDB replication would want to insert it, but then this trigger would stop it. And basically, it was a before insert trigger. You see, it's all quite simple. It just tested for the existence of something. And if it did exist, then it would return new, basically meaning it would do the insert. Otherwise, it would return null and the insert would be silently thrown away. And that worked well because it was basically it was a design that involved Postgres filtering, xDB filtering and Postgres triggers. But because what you've got to remember is xDB, the session replication role is replica. Therefore, triggers don't fire and foreign key validation doesn't happen. So that's a bit of a problem. We're trying to get triggers to fire and we're running in replica mode. So what you've got to do there is you've got to do an alter table of the table name and enable replica trigger. And in that mode, when you're in replica mode, the trigger will actually fire. And that's the DDL that you would run to actually enable the replica trigger. So that it will actually run in replica mode, and it will only run it then in replica mode. Now, if you want it to just fire always, you can alternatively do alter table name, enable always trigger. And then regardless of the session replication role, it will always fire in that situation. Okay, so supposing replication stalls due to data issues. Now, sooner or later, replication will stall. No technology is perfect. And for example, there's ever-changing character sets that come with their challenges. So at MasterCard, we had a problem with smiley face. And so what you can do is, so what would happen is that you'd see an error in you would notice that replication had stopped and there's errors in the log. And basically then what you've got to do is work out what's gone wrong. So the first thing is to know is that xDB actually replicates in actually large batches of transaction blocks, and that's the actual size of that is configured in the config file, and it's a config variable called txsetMaxSize. MasterCard, we typically set that to 3000. So what that means is that it will attempt to read 3000 transaction blocks from the wall stream. So the problem then is, of course, it means that the actual error is not the next block to be read from the wall stream. So what you firstly need to do is to get to a point where the DML that's causing the problem is actually the next DML in the wall stream. So typically what you can do with that is set that txsetMaxSize back to 1, restart xDB, and then wait until the DML appears in the xDB log file. And at that point, the problematic DML is the current DML statement in the wall stream. And then there's two great functions that we can then use to actually analyze that and then discard it. So what you can do is you have to stop xDB because you can't do this PG logical slot peak changes when xDB is running. But once you've stopped xDB, you can actually have a look at what's the next DML in the wall stream without actually moving the wall stream on. And the function is called PG logical slot peak changes. First argument is the slot name, and the third argument is the number of transaction blocks you want to read from the wall stream. So what would happen then is you'll actually be able to see what the problematic SQL is. I should say it's not SQL when you actually do a PG logical slot peak changes, but it's easy to construct the SQL because it's typically what you will see is the table name, the action, so insert, update, delete, and then the new values. And if you've got replica identity full, you'll see the old values as well. And so then you can construct that SQL, and you can manually execute that SQL on the target node. And then you can then use PG logical slot get changes, which you'll see on the next slide, to actually move the wall stream on and basically skip it. But of course, you don't want that insert or update to be repeated on the original MMR node again. So that is, when you execute it on MMR node number 2, you don't want it to replicate back to MMR node number 1. So what you do in that situation is you do your begin transaction, and then if you update the RREP properties table as indicated there, set the value to current timestamp where the key is last MCR timestamp. That basically tells xDB when it sees that update inside a transaction block not to replicate any DML between there and the commit statement. And so if you then put your problematic DML after that point, so if I said that insert into test table, that insert into test table will not replicate back and won't, because it'll get stuck on the way back as well, because if it couldn't replicate it in one direction, it won't be able to replicate it in the other. And that's how you do that. And then of course how you move the wall stream on, you'll see on the next slide. And you can use a function called PG logical slot rep, PG logical slot get changes. Again, argument number 1 is the slot name. Argument number 3 is the number of transaction blocks that you want to actually get, and it'll display them on screen. So, but it basically skips them, so the wall stream will actually move on. And what you would then do is start xDB, check your log file, make sure there's no DML problems, and when you're happy, don't forget to set txsetMaxSize back to 3000 and restart xDB so that it then runs more efficiently. I say 3000, it's whatever the sweet spot is for you. We found that 3000 worked well for us and for our application, but you might find a larger or smaller value suits you better. So supposing you've got a similar but different problem in that you've got excessive replication lag due to multiple duplicate key violations. Now, the sort of situation this might occur is, for example, when xDB is restarted, the restart LSN that it reads from the replication slot may be too far back in time. So it may not have updated as the wall stream has been processed by xDB. And the other time I've seen this happening is at a situation where after populating a new MMR node, while it's doing the catch up, certainly on Postgres 9, we're on Postgres 9.5. On Postgres 9.5, it doesn't update the restart LSN for quite a while. So if for any reason that catch up dies and you have to start again, then it will actually, it seems to wind back and start again from the position where it started to catch up. And in that situation, there will be a lot of duplicate key violations. So the question is, what do we do about that? Now, the first thing I should say is there is a documented fix for this, and that is batch initial sync. Set it to false in your config and restart xDB. But of course, we're not talking about documented methods. We're talking about undocumented methods today. So what you can do is, similar to what we did previously, is change the batch size to 1 and restart xDB. So in your config file, set tx set max size to 1 and restart xDB. And what you'll see is, instead of it reading a batch of 3000, discarding the first item, reading a batch of 2999, discarding the first item, and repeating that, it'll just read one batch of SQL, attempt to execute it. It won't work, it'll move on to the next one. And that tends to work better, but it's still a bit slow. So what you can do instead is, if you know that you've got a lot of SQL that's been replayed or that's been played already, then again, you can actually use this PG logical slot peak changes, but instead of just looking at the next batch of SQL, look at the next 1,000 batches. Because you'll find, in your application, if there's a timestamp column on your tables, you can get you can actually have a look at the most recent replicated value, and you can have a look at what the timestamp value is in the wall stream. And if the wall stream value is behind, then you know that you can actually discard these 1,000 items. And that can work quite well in terms of, you can skip through, say, 1,000 at a time, instead of it's slowly skipping through one at a time. And eventually you'll get to a point where you'll actually recognize that the values you're really reading from the wall stream are actually newer than the values in the target database. So at that point, don't do a PG logical slot get changes. Instead, you can do one or two things. You can just let it start to xDB up and just let it replicate and error for those remaining transaction blocks. Or you can do a binary chop, that is, say, instead of peaking 1,000, peak 500, peak 250, peak 125, until you find that you've got DML, all of the ML has not been replicated, and then do the PG logical slot get changes, and then start xDB. And you should find very quickly that the duplicate errors will have ceased, and it then starts to replicate normally. And that can be a good alternative approach. The one thing is, be careful. If you get it wrong, you'll have data loss. That's very important to remember. So, and all I also wanted to mention is you could actually use peak, and so you could actually script that. This is what I'm trying to say in this. So that is, if you are confident that you understand the application well, and you're confident that there's not too many updates or deletes where you can't identify the version that's being updated or deleted, then you could actually script it to actually pass through vast quantities of wall stream data that has been replicated already until it finds transaction blocks that haven't been replicated. And but obviously you have to know your application well, and if you get it wrong, you're going to have massive data loss. So, but I've included that there because it is something that you can do. It's not something that I've done, but it's something that I was interested in doing. Okay, so now we're going to come on to the final topic, which is building a second MMR node using offline snapshot without data loss. Now, online snapshot can be slow when the database being copied is very large. So, for example, if you've got an MDN node, as we have, which is, say, 9 terabytes, then building a second MMR node using the online snapshot will take time. And it also has its challenges building a second MMR node, because our requirement is 0 downtime. So we can't just shut down the MDN node, build a second node, and then bring the two up. And also, you've got to remember that while you're doing a snapshot copy, that vacuum won't be removing the dead tuples, because of course the snapshot is basically telling MVCC that it's got to hold on to those dead tuples because it might need them. And offline snapshot is not supported by xDB when the MMR MDN node is taking live traffic. The reason for that is because of the risk of data loss. So what I'm going to show you here is basically how to build a streaming replica and then convert it to be the second MMR node. So the idea behind that is that it's usually quicker to build a streaming replica than it is to actually use the online snapshot copy. So I mentioned, so first thing that you want to do is basically build a binary streaming slave of the MMR MDN node. So you can use PG-based backup, or you can put the server into backup mode, copy all the files. Don't forget your recovery.conf and the replication entries in pghba.conf. And now this is the important bit. Once you've got that slave up and running, of course, it's basically a mirror image of the MDN node. So what you want to do at this point is create a replication slot in the MMR MDN node. And of course, this is why I mentioned this earlier, is this is a point where we're going to want to do that. And of course, I've described that previously, so I'll just gloss over the PG create logical replication slot function. And then once you've created that, very quickly, you want to promote that slave to be a master. And the quicker you can do this, the better. Now, I prefer to shut the slave down, remove the recovery.conf and start the server again, so it'll come up as a standalone master and PG is in recovery will return false. But you can also just use a trigger file and promote it that way. And at this point, once you've done that, you'll have the MDN node, and you'll have a second Postgres server, which is a read-write master. But of course, at this point, it's not in the MMR cluster yet. So what you need to do is, with this new standalone master, and definitely not the MDN node, basically you've got to drop the replication slot. You also got to drop the replication origin, and you want to drop the 3 schemas. Now, EnterpriseDB schemas, that is, and make sure you drop them on the new standalone master, not the MDN node. If you drop them on the MDN node, you've got to start all over again. So the next step at this point is you want to do an xDB offline snapshot, and there is a Java command for that, which is Java -add pubdb. And the interesting thing about this is that you just omit the initial snapshot argument from this command in order to do it as offline snapshot. And that should complete in a couple of minutes. And amongst other things, that creates all of the truncate triggers, for example, and will populate all of those tables that you need in the second MMR node. So at this point, we're nearly there. But what you want to do at this point is xDB will think that there's a snapshot still in progress. So do you remember we discussed much earlier about the has initial snapshot column on the xDB MMR pub group table? We need to set that to Y, because there'll be places where it still has the value I. So do that, and make sure you do it on all of the controllers, so both your MDN node and your new node. And there won't be a replication slot, and there won't be a replication origin. So you need to create those on the new MMR node as well. And then we're nearly there. So now it's time to start xDB again. Optionally, you might want to do a one-off synchronization with the Java -do synchronize, and then set your schedule for real-time replication using the Java -conf schedule MMR. MasterCard, we use a real-time poll period of 1, but there's a number of different options for that. But basically now it's up and running, and we haven't had data loss. How do we know we haven't had data loss? How do we know we haven't had data loss? Because you'll see in the log duplicate key violations. Because of that gap between when we created the replication slot and when we promoted the binary streaming slave to be the master, there is some DML that was actually replicated. So I mentioned those techniques already, and you can either just wait for it to clear through those, because there shouldn't be too many, or you can use those techniques to speed it up. And basically, that's the end of the main part of my talk. So I hope you found that useful and informative. And all I was going to finish off by saying was just a very brief comment on EDB Replicate, which is the new version based on Apache Kafka. Now, I had a beta of that back in April 2019, and I was particularly interested in whether it could be configured to support multiple publications, because one of XDB version 6's problems is it only really supports a single publication within a Postgres database. And I see multiple publication support being a very promising way to improve replication performance. And that's what I saw. What I saw was it supported multiple publications within the same database, within the same schema, and within the same table. And that was exactly what I was looking for. So I was very pleased with that, and very much looking forward to when EDB Replicate is taken by MasterCard, which I hope it will be. Thank you very much indeed.
Hi.
So we're hoping to have some
is, to what
questions and answers now.
Yeah. So to what degree you see xDB helping up to solve your use case?
The great thing about XDB and the way that it helped our use case considerably is because of the fact that when previously we were using binary streaming replication, the problem there is that your slaves are read-only. And the great advantage of XDB and MMR generally is the fact that suddenly your secondary nodes are also read-write. So you can then start to redesign your application for code processing. It also makes, if you've got a primary and secondary site, which is actually the way ours is architected at the moment, then it makes failover easier and quicker. And ultimately, we're not quite there yet, but ultimately it should be pretty much instant. And we saw XDB and MMR as basically being part of the journey to get to that point. Whereas the problem with binary stream replication, as I say, is there's a delay while you're trying to promote your slave to be the master. And then we were trying to eradicate that. It also means that when it's read-write, you can take your secondary nodes offline and do maintenance on them. And we saw that as being another big advantage. I think, does that answer the question? Is that answering the right question?
Yes, I think so. Got it. And thanks for that. We have another question which
You're welcome.
Talks about how often do you see the replication stalls due to the DML changes, and how long does it take to fix the stalls?
Okay, so we don't have that problem very often. We had a particular issue with it, I mentioned, with the smiley face character, and we think that was probably someone purchasing online using their phone and managed to get a smiley character in there somewhere. And in terms of how long does it take, obviously the first thing is the monitoring has to pick it up. Someone has to respond to it. So that it's how long does it take to respond to the monitoring? That there's a replication issue. And then it then also depends on whether your application is such that you can actually in the short term just restart replication and then fix up the shall we say the corruptions on the secondary MMR nodes later, or whether you have to fix them up immediately. We have to fix them up immediately. That's quite important for us. And being a payment gateway, it'd be financial transactions. So that's all manual. So it does take time. And typically, I'd say if we were quick, probably 20, 30 minutes. I had quite a lot of it scripted because it happened a few times, so it tended to be the same recurring problem. And of course, then you get to know the nature of the application. So what I mean by that is, for this particular case with the smiley faces, there tended to be a transaction block of particular inserts into a particular table. And so, because you're familiar with that, you knew what you were looking out for, basically. But it was manual, it's prone to error, and it was, I should say, EnterpriseDB did fix that one very quickly for us, so I was very pleased about that. But yeah, it's manual intervention. I'd say whatever technology that you're using, there are going to be situations where replication stops, and it's just a fact of life. Obviously, if everything was easy, they wouldn't need us. I don't know, does that answer the question?
All right. Yeah, it does. Thanks, Gordon. The next one we have is, what kind of transaction rate in terms of per Mbps you were able to achieve? And are there any upper limits for that?
Everything has an upper limit, and obviously it depends, because obviously nothing scales exponentially, and in our case, we're running it up to about 150 financial transactions a second, and it works well up to that sort of speed. And with our application, each financial transaction is typically something like 8 to 10 inserts into different tables. So what's that, say, 150 times 10? So we're talking something like 1,500 physical inserts per second, and we currently scale that up to about 250, 200 to 250 financial transactions per second, and above that, we do start seeing replication lag if that is sustained. So those are the sorts of limits that we see on that. And then you say, what are the solutions for that? That's one of the great things I see about EDB Replicate, is the fact it should allow us to better parallelize. So one of the fundamental problems of any replication technology is the requirement to do things in time sequential order. And so you've got two choices: you either do it in time sequential order, or you do it so that you just eventually consistent, more like the way NoSQL does it. And so with xDB, it replicates in pure time sequential order. And yeah, we were seeing for our application typically 200 to 250 financial transactions per second. As I said, that's typically 8 to 10 inserts per transaction is what we're seeing as the limit with the technology that we've got, the hardware that we've got, the bandwidth that we've got. And that's adequate for us at the current time for payment gateways. And like I say, going forward, the way to improve that is you can have multiple publications. So it's basically a great degree of parallelism. It's basically, I think, the way to go on that.
Right. Yeah, thanks for that, Gordon. One more question.
I beg your pardon. I was going to add more to that in terms of, obviously, the other thing to do is tune your application in terms of the amount of data that is replicated. So, for example, if we could reduce our number of inserts from 10 down to 5, then obviously we would double the TPS, the transaction throughput per second. That's all I was going to add. So there's a number of ways in which to improve the throughput. One of them is better parallelism of your replication technology. Another one is just tuning your application. So I beg your pardon. I felt I hadn't quite finished that question.
One is, if our rep table name has similar first 27 characters, what should be our naming strategy?
That's a good question, because I think actually with I don't think, basically the short answer is I don't know the answer to that. That's normally automatic generated. What I suspect is that it doesn't actually use that string when you're doing logical replication. And I think that's a hangover from the xDB 5 days and the trigger-based replication, because we have duplicates, and it does allow duplicates in that column, and so the naming convention, as I recollect, I'd have to check the notes on that one. That's quite a good question, Joe. I think it's start RRPT and then underscore and then the table name, and then it just truncates it at 27. And I think, but short answer is I think you can have anything in there. But good question. Maybe I should check that, because I don't know. I'm sorry. So apologies for that. You've caught me out. I'm not embarrassed. So I don't know if you said anything then. I didn't hear anything further then. Sorry. Sorry, Prashant, are you still there?
Yeah, Matt, that's all from the Q&A site.
All right, thank you very much.
Thank you, Gordon.